So this is the 7th of the 8 problems on the extra transformations problem worksheet. And again, the way that I have them described on the worksheet itself, this would be number 2 of the second part, where the first part only has reflections and translations, and the second part also allows horizontal and vertical stretches. So as in the previous problem, we're going to have something going on here with horizontal and vertical stretches. First things first, indicate the basic function. So we're taking a square root here, so that tells us that our basic function is the square root of x. And now let's think about transformations. So either pause the video here or just while I'm writing transformations, think about how many of them are there. Feel free to pause the video and kind of write them out for yourself to see if you're feeling good. Okay, so what do we have here? Well, we have this 1 and this minus on the outside. That's going to be 2 transformations. The minus is going to be a reflection. The 1 is going to be a shift. We have this 2 on the inside. That's going to be a compression or a stretch, horizontally or vertically. And then we have this plus 1, that's going to be another shift. So we have 2 shifts, a reflection, and a stretch or compression. Let's do the stretch/compression first, then the reflections, then the shifts. Okay, so first of all, this 2 is on the inside. That tells us that we're impacting the x coordinate, and that tells us that it's a horizontal. And then since 2 is greater than 1, this is a horizontal compression by a factor of 2. Now, just for the sake of argument, if this 2 had been on the outside, so if it had been 1 minus 2 times the square root of x plus 1, that would have been a vertical stretch. So it's all about, is the coefficient on the inside or on the outside when it comes to horizontal versus vertical. Okay, here goes. As in the previous examples, we'll go ahead and start our coordinate analysis at the same time as we are doing the description of the transformations. So let me actually write xy a little lower, like so. And this is an arbitrary point on the graph of f. So the horizontal compression by a factor of 2 does not impact the y coordinate. It leaves it alone, but it divides the x coordinate by 2. So just after the compression, we end up at 1/2 x comma y. Let's do the reflection next. So we have this minus on the outside here, so that's going to be a reflection. Because it's on the outside, we're going to reflect in the x-axis. And since we're starting at 1/2 x comma y, the x-coordinate is unchanged by the reflection in the x-axis, but the y-coordinate is rendered opposite. So we're ending up here at 1/2 x comma negative y. Okay, now let's do our shifts. Kind of doesn't matter whether you want to do the vertical shift or the horizontal shift first. Let's do the horizontal shift. Let's get it over with. So again, this is exactly the same conversation we had in the same problem. If there had been no 2, if it was just x plus 1, that's a shift to the left by 1 unit. But we've already compressed by a factor of 2. So just like we said in the last example, every single x unit has turned into 1/2 an x unit. So what would have been a shift to the left by 1 unit, since it's happening after the compression, is now a shift to the left by, say it with me, 1/2 a unit. Yes. So shift left 1/2 of a unit. From an algebraic standpoint, one thing that some people find helpful is factoring that 2 out. So you could say 2x plus 1 is equal to 2 times x plus 1/2. So what doing that shows you sort of algebraically is where that 1/2 comes from. So since we first do the compression, after the compression, you've got an x plus 1/2 in there, okay? So that's one thing that sometimes helps out in terms of thinking of it this way. Okay, here we go. Let's do the coordinate analysis. So we're starting at 1/2 x comma y. The shift left is not going to impact the y coordinate. It'll just impact the x coordinate. It'll subtract a half from it. And again, we already did the reflection in the x-axis, so let's not forget that negative in front of our y. We have one more transformation left, and that's accounting for that 1 on the outside. So say it with me. What is that? That is a shift up 1 unit. Okay? So a shift up is not going to impact the y coordinate at all. Excuse me, a shift up is not going to impact the x coordinate at all. But it is going to add 1 to our y coordinate. So there we are, 1/2 x minus 1/2 comma negative y plus 1, and it might be nicer to clean this up, and it becomes x minus 1/2 comma 1 minus y. Okay, so that is the final destination of a point on the graph of f. So again, you started at the point xy, and then you wound your way through ending up here. Okay? All right, so the square root of x, again, we've graphed this many times before. So let's go ahead. Here are our axes. Just like in the previous example, I'm going to go ahead and say, since you're compressing by a factor of 2, it might be nicer to use a slightly bigger scale. So just like in the previous example, I'm going to go ahead and say, let's let 2 squares be 1, okay? So this is 1 on the x-axis, this is 1 on the y-axis. Now let's go ahead and plot the original graph. So that goes through the origin. It goes through the point 1, 1, and it goes through the point 4, 2. So here's 1, 2, 3, 4, and then 1, 2. So the point 4, 2 is up here. So there is our original shape. Okay? Let's label so that we're not thrown off by the bigger scale. Okay, so here we go. So we're taking 3 points on the graph of f, 0, 0, 1, 1, and 4, 2. And we are plotting them as points on the transformed function. So again, remember that x becomes x minus y/2, and y becomes 1 minus y. Okay, here we go. So remember, again, we plug the x values in for x and the y values in for y. So we end up with x minus 1 comma 2. X minus 1/2 is negative 1/2. 1 minus 1, 1 minus 0 is 1. When x and y are both 1, x minus 1/2 is 0. 1 minus y is also 0. 4, 2, x minus 1 is 3, over 2 is 3/2. And then 1 minus y is negative 1. So here, that 2 square scale is actually going to be really handy. Check it out. So 0, 0 becomes negative 1/2, 1. So that's up here. I'll actually label here just because the scale is different and I really want you to see it. 1, 1, that morphs into the origin. And then 4, 2 morphs into 3/2, comma, -1. So 3/2, comma, -1 is down here. So see, it's the same shape, but you can almost imagine that someone took like a bar and squeezed it in so that everything is kind of shorter and squatter. Okay, here we go. There is our graph. So it's the same basic shape, but of course we see that we've got a compression. It's been flipped over the x-axis, shifted left, and shifted up. One more time just to make sure, we've indicated the basic function. We have listed out all of our transformations. We performed the coordinate analysis, and we graphed both functions, labeling at least 3 points on both graphs. All right, one more to go.